Video, we're going to take a look at whether or not there is a correlation between a golfer's biorhythm and their golf score. And for those of you who aren't familiar with biorhythms, it is this pseudoscientific theory that we have cycles in our lives, that our physical well being, our emotional well being, and our intellectual well being follows these cycles, right? And the time is going to be the elapsed time from when you were born until the current date. And so you can see the physical cycle has a 23-day period, 28 and 33-day period, and this is a sine wave. So it bounces between -1 and 0, 1, right? So for any individual, you can calculate what your biorhythm is by simply inputting your birthday and inputting what the current date is, and then calculating it by one of those formulas, right? So this would be a case where all the three waves are kind of in phase, and this person has, as at the low of their physical, emotional, and their intellectual health. We're over here, right? If we look at this was about June 22nd. If we look over here on February 5th, now they're all at their peak, right? So these don't necessarily match up in phase all the time, but they go up and down. So at any one time, you can be any one of these either above or below the zero, but between zero, -1, and 1 on your biorhythm chart, where the more you are towards 1, the more you are doing well in that category, and the more you're towards -1, the less you're doing well, right? So this is some pseudoscientific theory that I think came about in the 60s. And there have been some people who have questioned, well, does that translate over to predicting a person's golf game? I don't remember who, but there was one golfer who won the US Open, and I think all of their biorhythms were at their peak. And so people started speculating, well, maybe you can predict a person's golf score with the biorhythm. And I thought that's super interesting. I like playing golf. No one's going to accuse me of ever being a good golfer, but I enjoy the game. I like playing. And I know, when you're playing golf, boy, you really have to have your emotions in check, your intellect in check, and your physical ability to swing freely in check. So I could really kind of see where if there's ever a sport where biorhythms might be a predictor of performance, it may be golf, right? So that led me to do some investigation. We're going to do this investigation in R. And I went ahead and titled this Biorhythms in Golf. And the first thing we're going to do is grab some databases and read them in. Let me show you what those databases are. The first database here is just the birthdays. And so you can see that I have the last name, the first name, and then also the date. And there's no header on this file, right? So this is a CSV file for birthdays with no header, but you can see what the information is. The next data file that I have is going to be the game logs. And so this data file contains, for the year 2016, the different tournaments, the different players, their salaries, a lot of information here about the scores that they had in their rounds, their total score, and then some information about the number of eagles, birdies, pars, etc. And then this DK score. Now, DK stands for DraftKings, and I'm going to use that as a predictor of a player's performance because that gives a score to how many birdies, eagles, pars, bogeys, etc. that they have. So I think it's really a true indicator of the player's performance that's kind of independent upon other players, right? So if we just said how they finished in a tournament, well, maybe other players weren't playing well either, right? But this DraftKings score is kind of independent of the tournament, although of course it's they have to score on the holes at that tournament. But I believe it's a much more universal measure about a player's performance. So we're going to use that instead of using their total score or their place in the tournament or anything like that. Okay. So you can see here we go, the year of the tournament, the date of the tournament, and then also the player, Rory McIlroy. So this was probably the final round, the fourth round, which was 9-25-16 of the Tour Championship. But we're going to just go ahead, and even though that's probably spanned over multiple days, we're just going to go ahead and use one day, which is probably the last day when round 4 was played, as being indicative of the biorhythm of this player for that tournament. Okay. So these are the databases that we're going to use. So let's go back here to R. The first thing we have to do is install some packages, dplyr, tidyr, and lubridate. I'm going to use those. If you haven't already done so, uncomment those lines and run it. But I've already installed them, so I'm just going to load those libraries. So now R has that necessary information that it needs to do the calculations that I'm going to ask it to. The next thing I'm going to load is the birthday file, right? So I'm going to read that into this, this birthdays object here in R. And note, I put over here header is equal to false, right? Since there isn't a header, I need to tell it that there's no header. Read.csv, and this is the path that I have to that. If you don't have the path, I put that in because it's easier, but you can always put, what is it? I think read dot or install dot, well, I forget what it is. There's a command you can use in place of that, but I just went ahead and put the path there. So let's go ahead and read it in. So now this birthdays has those elements in it, right? It's this data table that has, or data frame, which has the last name, the first name, and the date. But notice this date is actually a character. It's not being recognized as a date, but it's being recognized as a string. So we're going to need to fix that, right? The first thing I'm going to do is go ahead and add columns to this. So I'm going to use call names, birthday, last, first, and birthday, okay? So call names for this data, data frame of birthdays. And there we go. Now you can see it's popped up, last, first, and birthday. And then we're going to use as.date to convert this birthday from a character to a date. Perfect. So now we have the data in R, and we have it structured the way that R wants to use it to be able, or the way that we need it to, so we can use it later. The next thing, let's load in that database from 2016, right? So we need to grab that and suck it into R. Notice that in that database, I did have a header, right? So I'm not going to specify header is equal to false. In fact, I'm just going to leave it blank because it's going, well, actually, I guess I did specify that header is equal to true. So I told it header was equal to true, although it'll default to that. And then I also used the pipe saying that I want to separate, because if you remember in that file, let me pull it back up. In that file, this player, this column has both the first and the last name, but I want to separate that. I want to put the first name in one column and the last name into another column. So I'm going to use this separate command, which is a command in tidyr. And yeah, it'll separate, it'll take that player column and it's going to separate it into the first and the last using a space as a separation character. Now, a lot of people find it's easier to actually do a lot of the data manipulation in Excel and then bring it into R. But R, of course, has the ability to manipulate data itself. So anyway, we do that. We're going to read that in. Bingo, right? You can see here they had to discard some pieces because when they were separating it out, there were some people who had 3 names, some people had 4 names, and so they didn't really know what to do with some of them. So some pieces were discarded in here, and other pieces we're going to discard ones that we don't recognize because we just need to be sure we have enough to do a good analysis, but we're not going to mess with those funky cases. We're just going to get rid of them. So it turns out that this data file, we have 33 variables with 46,000 or 4,600 observations. So 4,600 rows and then 33 variables. And we saw what those are, but whoops, I clicked on, if you click on that, it'll pull it up. And here you can see it again, the year, the tournament, the date, first, last, salary, etc. Right? Finally, there's that DraftKings score and stuff like that. So, and notice that like odds didn't read incorrectly, but I'm not going to use that anyway. So I'm not going to worry about going and correcting stuff like that. I meant to do the drop down there, which I also like to use because now I can scan and make sure the variable type like character, integer. Oh, look, date's also a problem here, right? So the date is being noted here as a character and not a date variable. So we're going to need to go back and correct that also, right? So let's go ahead and join the databases and then we'll fix some stuff up. I'm going to do an inner join, which means it's going to match the first, the last, the rows in last in the database bdays to the rows for last in the database of data 2016. So in other words, it's going to match up, is the last name in one database matching with the last name in the other database? If so, it's going to connect those together into this new file. If not, it's going to discard them, right? So if it doesn't have a match, it's just going to be dropped, which gives me that inner join. And so if we take a look again at data 2016, you can see here, we end with odds, but we're going to do this inner join. And when we do the inner join, we look at this new variable dat, And you can see, let's see here. Oh yeah, it has the same stuff in it, but it now should put in the birthday. So over here we had the, let's see, on the DAT 2016, we didn't have the player's birthday, right? But now that we've joined these databases, it's put in this birthday file in there. And notice that it still recognizes a date. So it's interjoined on that. And essentially, it's added this one column to the data 2016, which is the birthday. And we're going to now call that DAT. If you want to, sometimes you can just pull it up by clicking on it here, but you can also type head of DAT. And you can look down here and get a quick scan and see, okay, well, the last name, first name, birthday, X1, year, tournament, right? A lot of this stuff we're going to end up dropping. But you can see that at least the first 6 observations are all for this one golfer. Here are the tournaments they played in, right? Here's the money, here are the scores, and here's that golfer's DraftKings. And that's what head does. It always pulls up the first 6 observations of what otherwise is a really big data table, right? So now we need to convert this date column here, right? As we saw, this date column is being recognized as a character. So let's go ahead and convert that to a date, which we just did. We now need to calculate the difference between the date for of the tournament and the player's birthday. And we're going to put that in a new column, which we're going to call diff days. Okay, so we're going to go like this. There we go. Now we've created that column. We're now going to convert that column to being numeric because I want to use that column in that formula to calculate the biorhythm. So let's go ahead and do this. And now we've converted it to numeric. So if you look down here, you can see diff days, which is right here. It's now recognized as a number. And this is a number of days between when the player was born and the tournament. So for the first player, let me go ahead and pull up DAT again. You can see that this player, Byung Hoon An, his birthday was on September 17th of 1991. The tournament was on July 17th of 2016, which means there were 9,070 days between the date he was born and the date of that tournament. This would be the days until that other until the tournament of the Open Championship, WC Bridgestone. There were 9,056 days between the date he was born and the date that he played in the WCG Bridgestone tournament. Right? You got the idea. So now that we've got that, we can calculate the biorhythms. Right? Because if you remember back to that formula, the biorhythm was a sine function, which had 2 pi times the difference in the days divided by the period. And for physical, the period was 23. For emotional, the period was 28. And for intellectual, the period was 33. And then I did a cumulative, which just was the sum of those 3. I could have also done just the average, like in what I showed you there at the beginning, actually had the average of the biorhythms, but the average is just the sum divided by 3, right? So it's telling us the same thing. It's just now it would go between -3 and +3. But that's going to define these variables, and it's going to add them. So it's going to add a column for physical, add a column for emotional, add a column for intellectual, and add a column for cumulative. So this file DAT, or this data table DAT, is now going to get these 4 additional columns. So if we run those, we can now come back here and say, oh, okay, well, for our player, our first player, who is this Byung Hoon An, he on the Open tournament, he had a physical biorhythm of 82, an emotional biorhythm of -43, an intellectual biorhythm of -81, and a cumulative of 0.42. So he was very high on the physical, very low on the intellectual, and medium low on the emotional, right? Because you have to remember the biorhythm one's between 1 and -1, and the emotional then would be a -0.5, would be kind of midway between 0 and -1. So he's doing well physically, not doing well intellectually, and doing not so well emotionally, but not, about halfway not as well emotionally, right? And we can do that for all of the tournaments. So this was the last tournament, and then the next tournament, the next tournament, the next tournament, and then we sum them up. And so 0.42 would be the sum of those. So overall, he would be off, he would be a below normal, about halfway below normal to his low peak, right? If we were to sum them all up. Perfect. So that's how we're getting the data. And just one more time, just to look at it another way, you can see here, again, here is Bjorn on the open tournament. And you can see here, these were his biorhythms for that tournament. And that was his cumulative score. And then we're again interested in this DK. We're going to use that DK as a measure of performance, that DraftKings score for this player. Okay, so now that we've done that, let's just keep the columns of interest. So we're going to take that DAT file. We're going to put it into a new object, which we're going to call DAT2. We're going to take that DAT file. We're only going to keep the last name, first name, the DK score, the physical, emotional, and then their biorhythms. Okay, so we're going to do that. We're going to get this new object DAT2, which is going to have a data frame, which is going to have just those. So we get rid of all that other stuff. And then we want to drop the NAs. There's some of these that have NAs which are not applicables. For whatever reason, they didn't have the score entered, or they were cut, or who knows. So we're going to get rid of those. We're left with this data file DAT2. Now let's go ahead and take a look at Jason Day, who's one of the golfers who's a really good golfer. Had a really good year, I think, in 2016. Let's look at him. When we look at the first tournament he played in, he had a DK score of 18. That's not good, right? A DraftKings score of 18 means he didn't have a lot of he probably had a lot of bogeys, not a lot, probably not any eagles or many birdies. In fact, he probably end up being cut that tournament. But if we look at his biorhythms, on that day, he had a physical biorhythm of 0.14, an emotional one of negative 0.62, and an intellectual one of negative 0.28. So those aren't really strong. I guess emotional is kind of, low, because remember, it's between -1 and +1. So that's kind of towards the low end. The physical and the intellectual, they're kind of closest to 0. But his score wasn't that good. So it's like, okay, well, maybe that makes sense, right? And if we look at his cumulative on that first tournament, a negative 0.76. So that is kind of low, right? Overall, he kind of had a lower type of score. But remember, those actually can sum to 3. So not really too terribly low, but he didn't have a good score. So that kind of makes sense, right? Kind of would support this biorhythm theory. Well, let's look down here and, I see he's got 100.5. So in this tournament, this 5th tournament, he had a really good tournament. So let's look at his biorhythm scores. A 0.27, that's not too far off 0. But wait a minute, a negative 0.62 and a negative 0.81, right? So intellectually, he's getting really low, right? He's getting to that point where he's getting at the bottom of his intellectual cycle. Cumulatively, he had a negative 1.16. So we would think that because these are so negative that he would have a bad DK score, but he doesn't, right? His DK score is 100.5. Not too supportive of the theory. Let's look here. At this tournament, he had a 115, an even better score. But let's look at this. He had a -1 on his physical biorhythm. That's at the bottom of the peak. So that's as low as he could go. He had a negative 0.62 on the intellectual, or on the emotional, and then also a negative 0.28 on the intellectual. And if we look and we sum those up, that's going to be, let's see, the 11th tournament, a negative 1.9. So his biorhythms here are all really low, but he had a really good golf game, right? So just by looking at this one player, it's like, I'm not quite sure if this biorhythm theory holds for Jason Day. But maybe it's just Jason Day, right? We have many different players that we're looking at. So let's go ahead and look at all of the players that we have, not just Jason Day, right? And so we're going to do that by filtering this data file. We're going to, first thing we're going to do is group it by last name. So we want to look at Jason Day's, the tournament that Jason Day played for him, right? So we're going to group it by last name. We're also going to filter, and we're going to say that all the golfers must have played in at least 5 tournaments. You can't really calculate a correlation coefficient with less than 5 observations. So They're going to have to play in at least 5 tournaments or we're going to get rid of them. We're then going to take a look at the correlation between the DK score and then their cumulative biorhythm, the DK score and their emotional, the DK score and their physical, the DK score and their intellectual, right? So we're going to take a look at the correlation between each player's DK score and their biorhythms, okay? And we're going to create new columns for that. Mutate means give me a new column or create a new column. So we're going to create 4 new columns: core cum, core emotional, core physical, and core intellectual. And we're going to append those on to this this data 2, right? Into the data 2 that we have here. And you can see that I've already run it here. And then we're going to only select those who are, we're only going to select certain columns there because we don't want all the columns to have a bunch of stuff we don't need. And we're only going to keep 1 row for each golfer, right? The correlation, once you calculate the correlation for Jason Day, it's going to be the same for all the rows. So we have 21 rows here for him. We're going to append it on to these rows, and we're just going to keep one of those, right? So we're creating this new data table called data grouped. Let's go ahead and run it. And you can see now when we do that, we have 159 observations of 6 variables. Let's go ahead and pull this up to look at it like this. Here we go. We can see we have Biorhythms on. Here are his correlations between his golf score or his DK score and the cumulative biorhythm, emotional, physical, and intellectual, right? So again, the correlation between his DK score and these different biorhythms. And we have it for each one of the golfers here. And we have 159 golfers. So we have 159 different golfers that are left after we filtered them out. We made sure they had at least 5 games, right? We made sure that we got rid of NAs. We got rid of those who maybe didn't have scores entered. And we're left with 159. So a pretty good size sample, right? A pretty good chunk of golfers we have to look at. And again, here's the breakdown of that data table. But this is even a better way to visualize it than trying to look at this, right? So let's go ahead back to our file and say, all right, well, here it is. Another way to look at it, right? We can look at it over here, but if we were to just run it and display it in R, we would get the same thing. We'd get this table down here. And notice that one of the things that I noticed right off the bat is a lot of these are near 0, right? If we take a look at this, many of these correlations are near 0. So if it's near 0, what does that mean? No correlation, right? You have to, your correlation is going to be between -1 or +1. -1 would be, fully negatively correlated. +1 would be positive, but 0 would mean no correlation. Most of these people have no correlation, right? Or many of these observations are close to 0. What's something else I noticed here? There's a lot of reds, right? A red means a negative, and that's not what we're looking for. A negative correlation would say, hey, as the player's biorhythm goes down, or as that particular biorhythm gets smaller, their expected DK score, it goes up. Well, that's just the opposite of what we want, right? So I'm seeing that a lot of negatives in here. So right now I'm going, hey, things are not looking good, right? It's starting to look like, just by visual inspection, that there's a lot of them which are near 0, or there's nothing that's really too terribly strong, near 1 or -1, or ideally near 1, but also have a lot of negatives in here. So, whoa, that's not really good either, right? So let's go ahead and, say, okay, well, I'm looking at this individually for each player, but let me go ahead and say, let me look across all of these 159 players. I'm going to look at the correlation between their biorhythm and their DK score for all of these different biorhythms. And I want to look across them and see what is the average, right? If I average these together, what do I get? If I then look at the other summary statistics, the quantiles, the max and the min, what do I get? So I'm going to run this summary command. And first thing we're going to do is take a look at the correlation between the cumulative biorhythm and their DK score, right? So that's saying I want to take the summary from the data grouped table and look at just the column for the correlation of the cumulants, or the correlation between the cumulative DK score and the the cumulative biorhythm. And what do we get here? Well, the mean is essentially 0, 0.004, right? The median is negative 0.01. So both of these, the mean and the median, are both just about 0, not much different from 0. The first and the third quartile, they're also near 0, negative 0.16 and 0.14. So for these middle 50%, really everything is really close to 0 between, negative 1.6 and negative 1.4. Okay, but let's take a look at the min and the max. Well, the min is negative 0.57 and the max is 0.68. So the min and the max are kind of, negative 0.57, 0.68. They're kind of similar-ish, but I don't want to see anything negative here, right? If this biorhythm theory held that golfers are going to do better on the days that they have high biorhythms, I would expect to see nothing negative. I would expect the minimum to be, not negative 0.57. I would expect the minimum to be, 0 or so. I would expect there to be a lot of positives, but there's not. And so the fact that it's so equally balanced between the positives and the negatives are telling me there is just no correlation between this, right? There is no correlation between the golfer's performance and their DK score. Most of the time that correlation is 0, right? Or it's 0 on average. Half of the people are better. Half of the people have a positive correlation and half the people have a negative correlation. And then it's pretty much equally distributed amongst the positive and negative correlations if it's not 0, right? Which the negative correlations are telling me that it's just the opposite of what we think the biorhythm theory should be. And it's equally spread against the positive and negative. So you can look at this as being some distribution, with the majority of it being here in the middle between, 0 and the negative 1.6 and 1.4, and the tails going out pretty much equally on both sides. And so there's no evidence, right? There's just no evidence. There's no strong evidence that, that the positive biorhythm or that positive correlation exists. Well, maybe it's just a cumulative. Maybe we could say, hey, when you golf, it's really about emotions. You've got to keep your emotions in check and not let yourself overthink things or become reactionary to bad shots. So maybe it's not the cumulative. Maybe it's just the emotional biorhythm, right? Let's take a look at that. Right, this has it in scientific notation, but again, the mean and the median are essentially 0. The upper is 0.67. The lower is negative 0.69. The first and the third quartiles, 0.16, negative 0.17, same thing. So not just the cumulative, but if we look just at the emotional biorhythm and their DK score, their performance on the golf course, that likewise, there's no correlation there. There's no evidence. Most of the time, the middle is no correlation, but there's no evidence based on these summary statistics that there is any correlation. If we look at the physical, yep, same thing. If we look at the intellectual, same thing, right? They look very similar, all of these summary statistics, and for the correlations, and it's just not there, right? Again, I don't want to say it over and over again, but most of the time there is no correlation, and when you look about the spread, the min to the max, it's equal on both sides. So it's indicating that that's just random chance which is popping up there. So I thought that this was very interesting. Like I was saying, when I was a kid, I ran across biorhythm theory. I thought it was kind of cool, and I'd heard this stuff about different golfers and correlations. So I thought it would be fun just to do my own investigation, and I hope that you find this interesting too. If you have any questions, please give me a comment or send me a message. Thanks. Bye.